All right, for the second part of Chapter 11, we are going to talk specifically about understanding and creating stem plots. These are also referred to stem and leaf plots. I'm sure you guys have seen them before. It's just probably been a while. So we've already talked about histograms as a way to graphically display quantitative data. Stem plots are another way to display this data, also called stem and leaf plots. But basically, these are quicker ways to make and present more detailed information. They're good for really small data sets, not so much like the big data sets. They show how individual quantitative values are distributed within a data set. So this slide just goes over the steps to make a stem plot. Step 1, which my numbers don't show, determine your stem and your leaves. So your stem is going to consist of all but like the final digit. Typically, we do like the tens place or the hundredths place. Your stem can have as many digits as needed. The leaves are the last digit. So the very last digit could be the leaves. Step 2, you're going to write your stems in a vertical column with the smallest at the top, and then draw a line. And then step 3, you're going to write each leaf in the row to the right of the stem in an increasing order from the stem. So they have to be in increasing order in both places. And then step 4, you're going to make sure you include a key, which we'll talk about how to make those. All right, for our first example, we have that Consumer Reports magazine presents the following data on the number of calories in a hot dog for 17 different brands. And my slide cut off a few of them. There's 173 and 136. So there we got 17 brands. We're going to make our stem plot. So what we're going to do, move this around. Why don't we use the first two numbers for our stems? So our lowest number is this 107. So our stem for that is going to be 10. And then we have to go all the way up to 191. So our stems have to go all the way up to the 190s. So this, like the 10 up here is going to be like the 100s. The 11 is going to be the 110s. The 12 is going to be the 120s. The 13 is the 130s. 14 is the 140s. 15 is the 150s. 16 is all the 160s. 17 is the 170s. 18 is the 180s. And 19 is the 190s. So now we just kind of start putting them in there in order, like our line. So our first number was 107, so 107, did that one. Even though we don't have anything in like the 110s and the 120s, we still have to have those stems listed, even though there's no leaves in them. So let's see, in the 130s, we have a 136. We have a 135 first, so let me switch those two. So we have 135, then 6. The leaves have to be in order. 138, 139, okay. Let's see, 140s, we got a 140, a 146, and a 147. So 46, 47. No 150s, no 160s, 170s we got. So we got a 72, a 73, 73, and a 75, 73, 75. Oops, I missed this 153. There we go. 179, 182. We have a 190, a 191, and a 195. So let's check. We have 17 numbers. 1, 2, 3, 4, 5. Yeah, we have 17 numbers, so we're good. Now, for our key, which is just off to the side, pick any of the numbers. So let's say we picked the 115 or 150. So we would write 15-3 equals 153. You can pick any number in there. You're basically just giving a key to show you kind of what this means. So our key gives what our stem is and what our leaves are. In my last video, we talked about histograms, and we made a histogram for, it was a table that was given in the example, and it was the percentage of residents 65 and over in all of the states. Now, for this one, if we made this a stem and leaf part, the whole number part would be the stem, and the final digit would be the decimal, basically, the 10th place. So like, for instance, if we had like a key for this, it would be 13 in our line and 8. This would be 13.8. That's the Alabama entry. Stems can have as many digits as we need to, and our line there can kind of often represent our decimal point. If we have like one value after the decimal, it works. Let's see what this looks like. Okay, here's the stem plot that they made for the percentage of residents 65 and over data. So you see that their stem was the whole number and the leaf was the decimal. So like, they have their key on the bottom here. They say a stem of a 7 and a leaf of a 7 means 7.7%. You can definitely do it like that. You can write it kind of how we did on the last one and say the 7 line 7 equals 7.7%. If it is a percent, I would always add a percent, or if it's money, add your dollar sign. Now, they kind of did working up where they did, first they just kind of did a blank stem, then they did the stems, so like this would be step 1. This is kind of their step 2 work where they did the stem and they had the leaves. Notice the leaves are not in order. So this one right here will be the final stem and leaf plot for this data. And so notice, we can kind of see our outlier here, that 7.7%, how that was an outlier. And we can see how the bulk of our data was between, 12 and 14%, because that's where most of the states were, between 12 and 14%. And you can see that in our data. What I like about about stem plots is that they're basically histograms on their side. The stems, or the leaves, kind of are going to be the same like height as your bars would be in your histogram. So like, the tallest bars, that is, our stem with the biggest leaves. So it's kind of very similar. If you put our stem and leaf plot, flip it on its side so it's horizontal, it would pretty much look just like our histogram. Like, it would kind of model, and they would kind of look very similar. The cool thing about stem and leaf plots, though, is you see your individual values, where you don't necessarily see the individual values for a stem or for a histogram. You just see like the number of values. So like, our histogram just gave us the number of values in 13%, like the number of states that had that, whereas a stem plot gives you exactly the values that were listed. It doesn't tell you which state was that value, but it gives you exactly each value that was in the 13 to 14% range. So kind of continuing on with what I was talking about in the last slide, one of the good advantages of a stem plot is it displays the actual values of the observations, not just the counts of the observations. They're faster to draw typically than histograms. Stem plots are not really that great with larger data sets because, often the stems can have way too many leaves and it can become kind of tedious and hard to do. In that case, a histogram will be awesome. But for small data sets, a stem plot is the way to go.